Greetings, this is Charles Darwin, and I'm in the Sonoran Desert of Arizona. And you can come out into the desert and find some of the most amazing adaptations to those hot, dry conditions. You can find them both in animals and in plants. Some of the adaptations to plants are represented by the plants that are behind me here. This is the palo verde tree, and it does not have leaves. Many of the desert shrubs have very small leaves or no leaves at all. This one does not have leaves. Instead, photosynthesis is carried out by the green stems, and therefore it's able to make food without losing very much water, and that's very important in the desert. Another adaptation is represented by the saguaro cactus that you see behind me. Now, some of its adaptations to prevent water loss are quite obvious. It's covered with spines, and that prevents animals from coming and eating its flesh or its tissues in order to obtain water. But there's something else that these cactuses do that adapt them exquisitely to the hot, dry conditions of the desert. They have a special type of photosynthesis known as crassulation acid metabolism, or CAM, C-A-M. It was first discovered by an Englishman, an eccentric Englishman, in my day, actually, and he had the habit of going around and eating leaves. I have no idea what he died of eventually, but he noticed that leaves of the plant family Crassulaceae tasted acid at night and did not taste acid during the daytime. It was more than a century and a half later when plant physiologists figured out what was going on. It was a special type of photosynthesis known as CAM, crassulation acid metabolism, named after that plant family, but other families such as the cactus family have it as well. And what happens is the normal photosynthesis occurs taking carbon dioxide and making it into sugar. But that occurs during the day when light is available, as you would expect. However, in order to let in carbon dioxide, it's necessary to open the pores and to therefore also take the risk of losing water. Well, what succulent plants do is they open their pores at night when it's cooler and there would be less water loss. The carbon dioxide comes in. Well, what could they do with it? They can't use it to make sugar because there's no sunlight. What they do is they store it up in the form of acid. And then at sunrise, they close their pores and carry out their photosynthesis using the supply of acid that they built up during the night. Exquisite, ingenious, isn't it? It seems like the kind of adaptation that would be very difficult for evolution to explain, and this is a point that is made over and over again by proponents of intelligent design. They say that complex adaptations have to be designed from scratch, either by evolution, which is very unlikely, or by a creator, which is what they claim. But actually, the truth is much more fascinating than that. And CAM is a perfect example. The enzymes involved in CAM are actually used by the plants for other purposes as well. The enzymes are not unique to crassulation acid metabolism. I'll say it right. They are used for other processes in plant physiology, and they have been borrowed. They have been applied to the prelude of photosynthesis by evolution. So evolution did not design crassulation acid metabolism from scratch. Rather, it borrowed the enzymes involved and applied them to a new use. That is a perfect example of the way evolution works and how it doesn't have to work from scratch, but can borrow existing processes and then put them to a new use. This is Charles Darwin. Tally ho, and amen.